All right, so in this one we're going to talk about permutations. And specifically we're going to talk about the cases that are actually difficult. If we had just a, let me break this title with a little discussion here. If we had n distinct letters or n distinct objects or n distinct people, which people are usually distinct, if we want to permute them, they're just n factorial ways of ordering them, right? And options for the first person in line or first object or first letter, and so on, right? N minus 1, n minus 2, and so on, ending into 1 options. Okay. All right, but we're going to do something more interesting. We're going to do permutations with repetition. And so not all the objects are going to be distinct from one another. So this is pretty atypical for ordering people, for instance. That would not be typical. Unless, of course, people are in specific groups, and group distinction was the only thing you're interested in. All right, so for instance, what is an example of this? All right, my favorite one to start with is the word banana. It has 2 N's, 3 A's, and 1 B. And we'd like to ask how many ways can we permute the letters in there. Well, you can see there's permutations or switches we can make that would make a difference. So like if we switch the B and the N, that would definitely be a different word. Now. But if we switched 2 A's, like if we switch these 2 A's, you wouldn't notice. Right? All right, so some switching matters and some switching doesn't. And so one thing we have to be careful of is if we were to like work through this from some sort of left to right process, we could get ourselves in trouble, right? So getting started is not so bad, right? What if so 1, 2, 3, 4, 5, 6 letters in this word? We can say, okay, how many options do we have for the first slot? Well, the first go with this is not bad. We can either do a B, A, or an N. So it would be 3 options. All right, but when we get to the next slot, it's not crystal clear how many options we have left. If we used a B, like in the word banana, we would only have 2 options left. But if we used an A or an N, we would still have 3 options. So this would be 2 or 3. And so we could not use the multiplication principle in this way. All right. Now you can start breaking it into all kinds of cases and work through it that way. But you eventually would just approach some sort of brute force strategy that wouldn't be very efficient. All right, so there's some good news here. So we can actually go through this in a very quick and easy way. We just need to think about how we place the letters. And let's start with, since we have 3 A's, that might be the most interesting place to start. So we have done this before. Let's first of all, our step 1 is place the A's. All right, there's 3 of them. We have 6 blanks. So essentially we just need to choose 3 of the 6 blanks to accomplish this task. Right, so choose 3 of 6 blanks to do this. And how many ways to do that? Well, we just need to do 6 choose 3. Right? So 6 choose 3 is the number of ways to do this. All right, now step 2 and 3 are going to replace the remaining letters. Step 2, let's place the N's. There's 2 of them. And we've used 3 blanks. There's actually only 3 blanks left, so we need to choose 2 of the 3 remaining blanks. Okay, we're not sure which 3 are left, but there are 3 distinct blanks left, and we have to choose 2 of those 3 blanks. So 3 choose 2 ways of doing that. In our final step 3 is to place the B. And there's 1 blank left, and we have to choose 1 of them. So while it looks silly, it's complete to have 1 choose 1 being the last step. All right, now our answer actually can be written in a variety of ways. Once you start doing this once, you can see, okay, well, first of all, 6 choose 3 times 3 choose 2 times 1 choose 1 Well, we could have done this in another order. And so if we do this in a different order, we actually are okay. Like for instance, we could have placed the B first. Right, so let's do these steps in reverse, but keep in mind we have a different number of blanks then. So if we place the B first, we'd have 6 blanks to choose from, and we only choose 1. So that would be placing the B. We give this the B step. Alright, and we could place the ends next. So there's 2 ends, so definitely choose 2 of them. And we have 5 blanks left. Okay, so that would be the end step. And then lastly, placing the A's, and there's only 3 blanks left. We're going to choose 3 of them. Okay, you probably would agree with me that if I was looking at this, 6 choose 3, 3 choose 2, 1 choose 1 is not obviously equal to 6 choose 1, 5 choose 2, 3 choose 3, at least not to me. But because we know we're completing the same combinatorial process of counting outcomes, and we're doing this correctly, these 2 quantities are going to be the same. You could check them. And you can actually do a few others, right? I think sort of a meta problem would be how many different ways can you complete this sort of process. Turns out there's actually like there's 6 different versions of this, right? Depending on which letter you start with and which you do next and next, right? All right, so this is just one way of going about doing this, and this is the book's first go at it. If you read the book, they actually refer to this as sort of a permutation look, and they have a specific notation for it. So let me make a note here. I don't want to use space badly. So the book, we refer to this as a permutation. They use a giant capital P. And they will have how many things you have initially. So in this case, 6 blanks. Then they use a colon. And then they put down these numbers. So in this case, this would be 3, 2, 1. This would be 1, 2, 3. Turns out they're all the equivalent to one another that way. So that's the book's notation for this process here. All right, now it turns out, I'll have a second sort of follow-up video to this, is that we can actually look at this instead of sort of a permutation look. We can think about this as something called a multi-selection. Okay, and this is not in the book, so you have to kind of keep an eye out for it, but it's a very handy tool, and so we'll take a look at this in the next video. All right, so I'll see you on that one.